Most people fail system design for the exact same reasons. They'll just mention Kafka, Redis without understanding the problem. Today I'll be giving you 10 tips to tackle any system design problem. Nail this order and you'll never freeze at the whiteboard. Hey everyone, I'm Bala Subramaniam. I'm currently a software engineer at the trade desk. Previously worked at JP Morgan, and I've also received an international offer to work in UK. I've been taking interviews from past 2 years, and I'll be giving insider tips to crack any system design interview. This is the first video of the system design playlist, and I will try to create videos on most asked system designs as well. Stay tuned, please subscribe to get notified. For any system design, it is essential to understand the requirements first, and in the requirements there are two parts: functional requirements and the non-functional requirements. Functional requirements defines what features does your system have, and non-functional requirements defines how your system works. So how do you get functional requirement? First things first, don't assume functional requirement without consulting the interviewer. Try to come up with a short list of the requirements which you think are corresponding to the system design you are designing, and don't add many features because you will only have around 40 minutes to tackle any system design interview if you have an hour of the interview. So try to limit the scope of the interview and let the interviewer know you're scoping the features, and if you get more time once you design the interview, you can come back and add more features. Functional requirements are the features you will be creating, like ability to upload a video on YouTube and ability to search for your videos on YouTube and stuff. And the next one is the non-functional requirements. This is very essential to make your system scalable and reliable. And then there are terms like consistency, availability, partition tolerance, and any non-functional requirements like search performance less than 100 milliseconds and high throughput. If you want, if your system is highly scalable and you want to handle around 1 million requests per second, don't just mention the terms like consistency, availability, partition tolerance. Almost all of the high scale systems have these terms in them. Try to match each term with your functional requirement. For example, for consistency, you can mention like a ticket is sold to exactly one person. So you don't want a ticket to be sold more than 1%. So you can match consistency with the feature itself. And the next thing is entities and relationship. Now that you have functional requirements and the non-functional requirements set up, now you want to get the basic core objects of your system, which are entities and the relationship between the objects. So entities are like actors and any core objects which are in your system. For example, ticket is an entity, user is an entity, server is an entity, reservation is an entity. And then there is relationships where you specify how two entities are related to each other. Is it like one-to-one mapping or one-to-many mappings? You'll draw something like this. You have a user where you'll specify the fields and the primary key and all those types, and you'll also have the relationship between like one to many, many to many kind of relationships. If you have an entity which is like a transient entity, a transient entity is an entity which is derived but not stored in a database, where you can specify that as well. That is optional, you can skip it, but if you have those kind of entities, you can also specify those entities. So now you have requirements gathered and you have entities specified. Then there is API design. It is very essential that you do API design after you do the entity and relationships, because most of the times entities result the core objects which you have created. So in that case, you can specify the entities in your API design as well. So before you dive deep into the API design, you'll have to figure out what APIs you'll be using. Not all the systems are using REST APIs. Some systems use GraphQL. For example, a social network system might use GraphQL instead of the REST APIs. And if some systems need a persistent connection, they'll use WebSockets. So try to figure out which API makes more sense for your system design. Talk through with your interviewer and let them know you are assuming a type of API. And then you create multiple APIs with their methods. For example, user login or user upload video. Just a quick hint, you don't need to mention login or register APIs because almost all of the systems have authorization and authentication specified. So let the interviewer know that you're not considering it. just assuming it exists. So you can feel free to add APIs for your functional requirements instead. And then there is load balancer, rate limiter, API gateway. These are something you'll have to know before you actually start designing the system, because most of the times you'll design a highly scalable system and you want to scale the systems independently. That's where you use load balancer, rate limiter, or API gateway stuff. It totally depends what type of system you're trying to create. For example, if you're creating monolithic service, you don't need the load balancer, but you still need the rate limiter and the API gateway. I'll try to explain the differences. So for load balancer, the name itself suggests that it balances the load, but it balances the load between the services which are very similar, which are exactly similar, like video service 1, video service 2, video service 3. These are just replicas, meaning they perform the same functionality, but you are scaling them so that you can handle more requests. In this example, you have 33.3% is being forwarded to each video service, so you can scale video services independently. And the next one is the API gateway. This is very similar to load balancer. It also is used to divert the traffic, but this is used to divert the traffic between different services. Here you have a search service, upload service, and a streaming service. And if a user is calling the search endpoint, that will be redirected to the search service. So API gateway makes sure the request is transferred based on the type of the request which it is getting. And then there is the rate limiter. So this is very essential in large scale systems where you don't want your services to go down because of a malicious client, where they are just keep on hitting your service endpoint and your service is not able to handle and it brings down. They use rate limiter and they pre-configure the rate limiter with a certain number of requests per second. Based on the configured number, here the first 2 requests goes through the rate limiter and the third request gets dropped, and it is either returned to the user saying 429 too many requests, or it is just dropped silently. Then there is monolithic versus microservices. So most of the times you will use microservices because in the age of AI the services are highly scalable, and nowadays monolithic is not primarily used. But it is good to know if the interviewer wants you to explain why you have chose microservices instead of the monolithic services. So the difference is that monolithic is a single entity where you have multiple processes running, and it is a single huge application, and it is simple to deploy because there is only one service, and the data models is shared between the processes instead of between the services, and it scales as a one unit, meaning it scales in a vertical manner but not the horizontal manner. If a part of the service goes down in the monolithic service, the entire monolithic service goes down. In the microservices, each microservice is independently deployed and independently scaled, but it brings a latency issue where each microservice will still need to talk with each other and stuff. So this is how it looks for monolithic. A single monolithic service, you have auth, orders, payments, and search as part of it, and then there is a shared database. For microservices, you would use something like API gateway, where you are redirecting the request between microservices. Now you have the load balancer and the microservices architecture, then the data storage. Almost all of the times you'll have 2 options, NoSQL versus SQL. It totally depends on what system you are trying to build. So if your system has more relationships between the entities, it is advised to use SQL database. But if your system has eventual consistency or a highly scalable use case, then you'll probably lean towards the NoSQL database. So try to understand the pros and cons of each database, and don't just assume the database without speaking with the interviewer. So let them know your thought process and then finalize the database. So then there is cache. So this is not an essential part of your system design, and it doesn't need to be part of your first draft of your system design. Try to get things rolling by adding the services and the database, and let the interviewer know that you'll be adding cache after some time based on where the congestion is. So sometimes if you forget to add cache, interviewer might probe saying your database will be bombarded with many requests, and you will have to take the hint and say we will probably use cache in between services. So when you're mentioning cache, you'll also have to mention the eviction strategy, meaning if your cache is full, how do you make a place for a new entry? So there are multiple eviction strategies like LRU, LFU, FIFO. So understand intricacies of these eviction strategies and explain the interviewer why you choose a particular eviction strategy. So this is an example where you have a cache in between your database and a service, and first time when clients want some data, the data is not present in the cache, so it goes to the database and updates the cache and returns to the client. And the next time if the request is performed, then it is just returned from the cache. So the next thing is the queues. When I say queues, it defines asynchronous versus synchronous. This is very essential because not all the systems are synchronous in nature. When you use synchronous strategy, your client will be blocked until your server performs a request. And when you use asynchronous, you can scale your services based on the requests independently. There are some part of the systems which needs the synchronous for sure, and you can combine synchronous and asynchronous in the same system design but different parts of the system. Like if you are designing a payment system, you need the payment API to be asynchronous because client will be waiting for the payment to be completed, and you can make the notification service as an asynchronous where you'll just push a message to the notification service and it is sent at its own time. Then there is databases versus blob storage. We already discussed we have NoSQL versus SQL, and that comes under the databases. And there are some use cases when you wanted to store unstructured data. So in NoSQL versus SQL, it is still structured. If it is NoSQL, it is most probably JSON. If it is SQL, it is a table. And if you want to store some data like files, audio, video, or anything as such, you will probably use blob storage. You don't just use blob storage or database. You will probably combine these two. For example, if you want to store a video, it has metadata and the video itself. So you will store metadata in the database and video in the blob storage, and then you refer the video S3 link. For example, you can use S3 as the blob storage. You can link the S3 in the video metadata in your database. So that's it. Just try to follow these 10 steps and you will come out of the interview with the flying colors. That's all for today. Please do subscribe.